Hi, this is Ned wearing my pajama to recording this video essay. And I got a graph here. The black line is my original function, and I got a random point f at a, which is this black point. And I drew a tangent based on this point, which is this blue line. And then I got another point, the orange point, which is a plus h at at and f at a plus h. And then based on those 2 points, I can draw a secant, which is this green line. Yeah, this one. And as you can see, uh, well, I can calculate the slope of those two line by I can I cannot calculate the tangent yet, so I need to calculate the slope of secant first. So here's the formula that I use it to calculate the slope of tangent. If the orange point is on the left side of the black point, which means it's on the preceding interval, I can use this formula here. F at a plus h minus f at a minus divided by a plus h minus a, and I can calculate the slope of secant, which is ARC, average rate of change. And what if the point is on the right side, which means the point is on the following interval of this black point, like this? I can use this formula to calculate the slope secant, which is FA minus F at A plus H divided by A minus A plus H. And here's a bracket. And I can also get a slope tangent, a slope secant, the ARC. But those two formula are the same because if I add a negative sign on the on the above, and I put another negative sign on below, then the the value doesn't change. But if I simplify this, those things position should exchange, so those two are the same. So I can pick either of them to calculate the slope of secant. Just give me a second. Okay, and so how do I get the slope of tangent, the IRC instantaneous 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 rate of change? I can I can well, if I make the distance, which is the edge, because a plus h means that the edge means the distance on the horizontal direction of these 2 points. So if I make it smaller and smaller, I think they are approaching each other very close, but not but not at the same place. At the same place with each other. I can I can do it for you. So you can see that the green line is getting near to the blue line as while I move the green point approaching to the black point. This is from the following interval. I can do it from the preceding interval too, like this. It's approaching 2. So I can get a formula out of this, which is the MT, the slope of tangent, equals to limit h approach 0 from the preceding interval. Here's let's see, here's a plus h is on the above, so I can write as this minus a, which is just this. Here's the formula of slope of secant, and Yes, fa plus h minus f at a. So I can simplify it into limit h approaching to 0 from the preceding interval. And here's my formula from the to calculate the slope of tangent. Since those formula of secant those formula of slope of secant are the same, so I can get another formula which can calculate the slope of tangent as well, based on the other interval, which is the following interval. So mt also equals to limit h approaching to 0 from the following interval a plus h minus f at a minus divided by h. So this is the formula of calculating the slope of tangent. You might say, I want to be convenient. I don't want to calculate both to confirm the slope of tangent. I want to use only one either preceding interval or following interval to calculate the slope of tangent. That's not right. That's not working, because for example here, if the graph of the interval x greater than 1 doesn't exist, which means the black area of this function doesn't exist. The graph is only the graph stop here by this one here. So at this point, it only has the preceding interval to calculate the slope of tangent. Then you got a value, and you believe that is the slope of tangent, the value of slope of tangent. That's wrong, because there's no tangent here. Just the graph stops here, and the graph stop. There's no tangent here because the graph stops here. There's no way to have a tangent without a continuous graph. But you can get a value by calculating the preceding interval. So we need to calculate both sides of the points we want to get the get a preceding interval and the following interval results, and compare with each other. If the values are close or same, then uh, will there will probably be the right answer. And yeah, that's it. And there's some limits of this thoughts, this formula. This whole formula is, if the point, like there's a hole at the point here, f a is actually equals to another value, at not on this curve. It can be called it is it does exist. So if I use the formula here again, then I get a like a then I get the preceding so then when I calculate the preceding interval, I will get a very large number, because it's really steep from the preceding to this higher point. And then when I calculate the following interval, the result should be very small. It's a negative a lot of 9, and a lot of nines, which means the slope of preceding and following are not matching. And then and then there will be no way to calculate the limits. Well, in fact, there's no limit. there's no tangent at this point. Why? Why? Because if I use this formula to why can I get the sort of tangent by using this formula? Because here fa plus h minus fa, they should be on a continuous function, which means fa should be very close to a plus h. The, those 2 points, the position should be very close. The orange point should be very close to the black point. Those 2 points should be very close. Then there's the idea of our whole work is like approaching. But in this condition, it does not approach to each other at all. So the limits here doesn't work for this situation. Um, and that's it. Thank you for your listening. Where's my OBS? Goodbye.